That multi-generational effect, for me, was huge, said Hunt. It would be a 50-year problem in humans. We think these effects are at doses that are environmentally relevant. She was saying that people today are exposed to similar levels per body weight as her mice. How would we see this in humans? She asked. Increasing rates of miscarriages, low sperm counts, testicular problems. We already do see that. How long will it be before we say, holy cow, are we crippling both sexes at once? Hunt is frustrated, passionate even, that US and many international agencies still have not taken a strong stance against BPA. As of this writing, though, 10 states have banned it for use in baby products. France has banned the substance from water bottles, and Denmark has banned it from food packaging meant for children under age 3. She reminded me of the once staid climate scientists who have become some of the most outspoken critics of US climate and energy policy. They know too much to keep quiet. In the meantime, no one in her lab drinks out of a plastic bottle. A couple of Pat Hunt's observations have big implications for breasts. The first is that diseases like cancer can start in the womb, even in the egg, in its earliest beginnings. The second is that synthetic chemicals that whack out our hormones are popping up in wholly unexpected places, like our grocery receipts. Since her first accidental discovery in the lab, hundreds of other scientists have also studied BPA, wondering, among other things, what it does to how the breast grows and develops. Numerous studies have confirmed that BPA activates the estrogen receptors on breast cells and can cause cancer cells to replicate in a dish. In addition, BPA has been shown to cause normal breast cells to act like cancer cells, growing invasively when they're not supposed to. BPA and similar compounds can turn on and off genes in breast cells in ways that foster cancer. When fetal or young rats are fed BPA, they can be more susceptible to getting cancer later on when they are exposed to other carcinogens. There is something about BPA that alters the way rats' mammary glands grow and respond to later threats. In other rat experiments, prenatal exposure to low doses of BPA caused lesions in mammary glands. When researchers at Yale fed DES, a very strong estrogen, to some pregnant mice, and BPA, a weak estrogen, to others, at levels approximating those found in pregnant women, both offspring's mammary glands produced more of a protein called EZH2. Higher EZH2 levels are associated with an increased risk of breast cancer in humans, and it didn't matter much to the glands whether they received the strong or weak estrogen. This was a chilling discovery for those toxicologists still clinging to the ages-old adage that the dose makes the poison. Cancer isn't the only concern. There is also some evidence that chemical exposures delivered very early in life can alter the way the milk-making structures grow, as well as rejigger the timing of breast growth during puberty. In industrial countries, human breasts are appearing earlier in childhood. Stay tuned for the next chapter. And women in the United States suffer from more problems breastfeeding than women in Africa or South America. It's treacherous drawing connections between lab rodents and people, but if our historical DES experience is any guide, the lab data can be telling. Our mammary glands are similar to those of rodents, and we are sensitive to the same hormones. These potent chemical signals are the ancient currency all vertebrates share. Estrogen is the oldest steroid of them all, with our cellular receptors originating over 550 million years ago. Our bodies inherited an eons-old ability to absorb it from our surroundings, even after we learned how to make it ourselves. We are a modern motif on an ancient device. Why are our estrogen receptors such disappointing judges of character? Why are they so promiscuous, hooking up with many different kinds of compounds? 2 reasons. One is a central theme of this book, so it's worth saying again. Organisms like us are designed to be biologically responsive to the world around us. Scientists call this phenotypic plasticity. It means we can tweak our bodies a little bit if it looks like we need to, regardless of our DNA. Our hormone receptors are sensors. They are one of the ways we gauge the world. The estrogen receptor, though, is confoundingly Catholic in its tastes, more so than the other steroid receptors. Its lock will take any key with a carbon ring structure and others besides. As bad luck would have it, this structure is the same building block used to make numerous synthetic compounds, including many plastics, solvents, and pesticides. Our breasts, for better or worse, have more varied and more sensitive hormone receptors than other organs. If anything, their receptors veer toward oversensitivity. They need to sense the environment to store fat and grow at the optimal time and feed an infant in an uncertain world. What might have been handy once upon a time now looks increasingly like a liability. This leads us to the second reason, which is that our receptors never before had to dance with so many bad actors. In the past, Estrogen mimics were mostly plant estrogens, and many of them are weak and possibly even beneficial. Some phytoestrogens block our receptors in a good way. Some studies suggest that high soy diets, for example, help prevent a recurrence of breast cancer in survivors, as well as delay breast development in girls, perhaps by protecting their cells from their body's more active estrogens. We co-evolved with plant estrogens, and that's probably why we can metabolize these compounds quickly. We were also exposed to them seasonally and in limited amounts. BPA, on the other hand, comes to us in a daily drip, and notably, reaches us in the womb. BPA was proved 80 years ago to act as an estrogen. You might wonder, as I did, why on earth, if BPA was known to behave estrogenically, did it go on to become the principal ingredient in ubiquitous polycarbonate plastic, an ingredient known to break down easily and escape into the environment? The answer to that would be a long and sorry tale about the lack of government oversight, inadequate testing, in fact, virtually non-existent testing, for hormonal effects in safety studies, and the phenomenal power of the chemical and pharmaceutical industries, a la big tobacco, to sow seeds of scientific doubt and maintain a favorable regulatory landscape. If known estrogenic compounds such as DES and BPA could fly so long under the safety radar, what about the other thousands of chemicals in our world, especially the ones that are not obvious hormone disruptors? How safe are they? In the United States, 700 new chemicals come to market each year, joining the 82,000 already in use. Of these 82,000, only a few hundred have ever been tested for health effects. Despite the 35-year existence of government regulatory agencies and their guiding laws in the United States, including the Toxic Substances Control Act, only 5 chemicals have ever been banned. DES was still manufactured in this country as recently as 1997. Unlike in Europe, American companies are not required to perform safety studies on chemicals before they introduce them into the marketplace. In fact, they have a strong incentive not to perform them. In the United States, every chemical is assumed safe until proved guilty. The burden to do that falls on government and university scientists who don't have the institutional muscle or resources to keep up. It takes years of work to prove that a chemical causes harm, and a shield of proprietary industrial secrets has kept manufacturers from revealing which chemicals they're even using. Those recipes may be private, but they swim in your bloodstream and in mine. Of the 650 top volume chemicals in use, 4 billion pounds get released into the American water and air each year. 42 billion pounds are made here or imported each day for use in products and materials. The U.S. government does occasionally single out some chemicals for lab animal testing, and the Environmental Protection Agency has recently finalized new tests for routing out the top suspected endocrine disruptors. The official tests, however, focus on certain well-established endpoints: the liver, the kidney, the genitals, and the brain. They leave the mammary gland in the trash can, pointed out Ruth Ann Rudell, a toxicologist at the Silent Spring Institute, a Massachusetts-based nonprofit that advocates stronger environmental testing. The mammary gland, once again, occupies a forlorn and forgotten place in science. This is especially disturbing since independent scientists have found that the mammary gland is the most sensitive organ to known culprits, such as BPA, DDT, and a common weed killer called atrazine. Banned in Europe but used in the United States to the tune of 75 million pounds a year, atrazine is a major contaminant of drinking water supplies. In the body, it appears to increase the activity of aromatase, an enzyme that converts testosterone and other hormones to estrogen. In affected frogs and fish, scientists are seeing damaged reproductive organs. Rats who are exposed early in life are showing signs of altered mammary gland development and increased incidence of mammary tumors. The journal Cancer reported in 2007 that limited testing, mostly by independent scientists, has so far found 216 chemicals known to cause mammary gland tumors in animal studies. These include chlorinated solvents, products of combustion, pesticides, dyes, radiation, disinfectants, pharmaceuticals, and hormones. 29 are produced at levels greater than 1 million pounds per year in the United States. 73 are present in consumer products or in food. Roughly 1,000 chemicals have so far been shown to alter animal endocrine systems. These compounds include anti-androgens and thyroid impersonators, not just estrogens. One of Rudell's projects is to corral various laboratories and agencies to develop standard tests for recognizing damage to the developing mammary gland. We've genetically modified our crops, to be able to protect them from the ill effects of pesticides, but we haven't yet figured out how to modify our breasts or livers or brains. Perhaps someday we'll have GMO breasts along with GMO corn. In the meantime, it's next to impossible to draw a line between a particular chemical in our lives and a disease or symptom that might show up decades later. When we do notice a problem with a common drug or chemical, it's because the resulting effects are either very unusual, rare vaginal cancers in DES daughters, mesothelioma in asbestos workers, or very obvious, shortened limbs in children whose mothers took thalidomide to prevent morning sickness. With DDT, the effects have been more subtle and more varied, but the eventual catalogue of ills, recounted by Rachel Carson and many others, make the endocrine disruption hypothesis possible. A chlorinated hydrocarbon, DDT had a great run during World War II as an insecticide, sparing soldiers from grim deaths by typhus and malaria. After the war, its manufacturers were eager to grease its transition to civilian uses. As Brigadier General James Simmons rhapsodized, "The possibilities of DDT are sufficient to stir the most sluggish imagination. In my opinion, it is the war's greatest contribution to the future of the world." It was sprayed from airplanes over fields, suburbs, playgrounds, and country roads. It was aggressively marketed to housewives and farmers alike. By 1950, it was so widely used that 100% of houseflies were resistant to it. Still, its use continued unabated, and by the early 1970s, 1.3 trillion pounds had been sprinkled, sprayed, and dusted in the United States. Many adults today remember gleefully running or biking through the fog sprayed by DDT trucks and planes in the 1950s and 1960s. After dead insects, birds were DDT's first notable victims. Most famously, the pesticide wiped out populations of bald eagles, peregrine falcons, and brown pelicans because it weakened their eggshells and altered nesting behavior. It wasn't long before scientists started looking for effects in other animals and humans. They measured it in human blood, umbilical cord blood, and breast milk, and they found associations between high levels of the pesticide and the incidence of diabetes, miscarriage, poor semen quality, shortened duration of lactation, preterm birth, low birth weight, and decreased cognitive skills in children. DDT and its main breakdown product, DDE, are very difficult to get rid of. Fat-loving, stable molecules, they reside in animal tissues as well as in soils and streams, and stay there for decades. 30 years after the ban, these molecules are still detected in most human blood samples tested by the Centers for Disease Control and Prevention. Several studies have compared the DDT levels in women with breast cancer to those in women without breast cancer. Nothing remarkable showed up. But then in 2007, researchers looked at blood samples collected from mothers in the 1960s. The younger women, the ones exposed to the most DDT as girls, at levels still measurable in their blood because of DDT's long half-life, had a 5-fold increase in breast cancer incidence later in life. The girls who were older than 14 when DDT was introduced had no increase in the incidence of cancer. For the girls who received their hits in early youth, the blow was much worse. In other words, the timing of the exposure was critical, similar to the effects seen of radiation in bomb survivors and BPA in mice. This study may well help explain why women born after 1940 have much higher levels of breast cancer than women born before. There were simply more chemicals soaking their childhoods. DDT was just the first in a line of troubling organic pesticides. Next came dieldrin, aldrin, chlordane, heptachlor, hexachlorobenzene, and others. After World War II, our thrumming petroleum and chemical weapons machinery readjusted beautifully to civilian outlets. Cheap byproducts of fossil fuel production found myriad new uses. Benzene became a building block for BPA, flame retardants, insecticides, and scores of other formulations. Today we use 30 times more synthetic pesticides than in 1950, nearly 9 pounds per person. When Rachel Carson wrote Silent Spring, she noted that 1 out of 4 Americans would get cancer in their lifetimes. Now the rate is 1 out of 2.5. An aging population accounts for much of that change, so it helps to look at age-adjusted rates for specific cancers. When we do, we see that the incidence is notably rising for endocrine-related cancers, such as breast, prostate, and thyroid. We now know many chemicals have the potential to cause cancer and much more subtle effects, as we'll see. It has taken 3 generations to find out. Chemical World News reacted to the publication of Silent Spring by calling it science fiction to be read in the same way that the TV program The Twilight Zone is to be watched. But the public responded to Rachel Carson, and by the mid-1970s, Congress had passed laws to begin to regulate the chemical industry. In 1972, DDT was banned. Carson wrote, "If we are going to live so intimately with these chemicals, eating and drinking them, taking them into the very marrow of our bones, we had better know something about their nature and their power." She'd no doubt be discouraged by the extent to which chemicals are even more embedded in our food systems and personal lives than they were 50 years ago, but she'd be fascinated by our increased understanding of how they affect so many bodily processes. 18 months after Silent Spring was published, Carson was dead at age 56. She had breast cancer. 6. Shampoo, macaroni, and the American girl. Spring comes early. Still, she went on growing, and as a last resource, she put one arm out of the window and one foot up the chimney and said to herself, "Now I can do no more, whatever happens. What will become of me?" Lewis Carroll, Alice's Adventures in Wonderland. On the afternoon Sonia Lunder came to visit, I was, as usual, madly making after-school snacks for the kids, who are 7 and 9. It entailed scooping some dip out of a store-bought plastic container, peeling carrots, and slicing some cheese. The kitchen is where love and guilt, those dual sirens of parenthood, merge at their most intense. It was a fitting place to begin planning a chemical body burden experiment. At the heart of the experiment lies one central fact. Girls today are getting breasts earlier than ever before. Lunder works as a senior toxins analyst for the Environmental Working Group. The mother of 2 small children, she has taken her knowledge of chemicals into realms I never imagined. At the gym where our kids take classes, she noticed the big foam blocks in the pit that students land in as they jump off a rope swing. She asked the gymnastics director if the foam was treated with flame-retardant chemicals, which are known to slough off and accumulate in human tissues. To his credit, he'd actually considered the question before and told her he tries to get untreated foam. She encouraged him in her friendly Sonia way to keep trying. In my kitchen, Lunder zeroed right in on the fridge. Even the door's water dispenser attracted her attention. "You know, the water tubing is probably plastic," she said. After noting all the plastic-contained food in my fridge, yogurt, juice, cheese, meats, she pointed to a cutting board on the counter. She asked if the original packaging had said antimicrobial on it. I shrugged. "If it did, that means it's embedded with triclosan," she said. She scrutinized my hand soap gel. I thought she'd be happy, because it was from a leading green brand and declared on the bottle that it contained no parabens. "Interesting," she said, reading the smaller print. "It's got benzophenone in it. That's related to a sunscreen chemical linked to endocrine disruption in animals. Why would they put that in your hand soap?" she mused. "It probably keeps the contents from breaking down in UV light." Lunder was here to help me prepare for the detox phase of my home experiment, in which I would valiantly try to avoid exposures to chemicals to see if I could reduce my body's levels of toxins. The experiment, designed with help from both Lunder and Ruth Ann Rudell, the toxicologist for the Silent Spring Institute, would incorporate a before and an after phase for both me and my 7-year-old daughter, Annabelle. We would compare our levels to those of 5 other American families in a study sponsored by Silent Spring and the Breast Cancer Fund, both non-profits interested in elucidating the environmental connections to breast cancer. In the first tox phase, Annabelle and I would live our normal lives, absorbing hidden molecules of plastic from our food and the occasional canned beverage, as well as from shampoo and moisturizers purchased from the supermarket. In other words, for 3 days we would be average Americans. Then we would pee into some glass jars and ship them to Canada for testing. A week later I would enter detox for 3 days. I would become a vegan, avoid triclosan and plasticizers to the best of my ability, and have my urine retested. I would not drive, to avoid chemicals in the car upholstery and interior, and would only eat food that had never touched plastic. As a testament to just how foreign this is to the American experience, I couldn't imagine getting Annabelle to undergo full detox. It would mean no vehicles, no pizza, no bubble bath. I didn't have the heart to put her through it. For much of phase 2, I'd be on my own. Why bother with all this? Blame it on the government. For 7 years, the National Institute of Environmental Health Sciences, NIEHS, and the National Cancer Institute have joined forces in a $40 million study trying to understand the forces behind early puberty and its link to breast cancer. I'd heard about the effort, called the Breast Cancer and Environment Research Centers, BCERC, and was closely following the results, which fall into 3 main buckets: chemical exposures, lifestyle, diet and exercise, and social factors, economic status, number of parents in the home, etc. Data have been coming out of 4 research hubs across the country in which a total of 1,500 girls were participating, beginning at the age of 6. Already the information shows these girls have some of the highest body burdens of everyday chemicals yet seen. As a group, they also have the youngest breasts ever recorded. I was curious to know how our levels matched up, and what it all meant. Scientists have known about the relationship between the age of puberty and breast cancer for a long time, ever since they began looking at lifetime estrogen exposures. Then in 1997, Marcia Herman Giddens, a scientist at the University of North Carolina, published a bombshell of a paper. Her research indicated that girls were developing breasts and sprouting pubic hair 1 to 2 years younger than expected, with white girls getting breasts at a mean age of 9.8 years and black girls at 8.8 years. Menstruation typically starts 2 to 3 years later. Within 2 years, experts revised the official definition of precocious puberty downward, from age 8 to 7 in white girls, and from age 7 to 6 in black girls. Welcome to the new normal.